we saw that we can form ionic bonds. Now, atoms can form these ions, either cations or ions, but it requires a removal of electrons, and either from an atom so that you can give it to one, or from an atom to form the anion. Atoms can have any charge you want. It just takes energy to do it. So what we found is that some situations are really high in energy. They don't ever occur, or rarely occur unless you force it with high energy. And then some are low in energy, and so what happens, because they're low in energy, they occur in nature. And that's what we're going to look at. Metals tend to become cations when they react with nonmetals. The low energy states, what you see happening in nature, is the alkali metals lose one electron. The alkali metals are the metals that are all the way over on in the left-handmost column of the periodic table. Next to those, one column over, are the alkaline earth metals, and they lose 2 electrons. Why is it they lose 1 electron and 2 electrons? Because of the number of electrons in the valence shell. Aluminum loses 3. Zinc and cadmium lose 2. There's missing and here. There should be a cadmium CD there. And then silver loses 1. The rest of the metals all can do a lot of different things. And so I'm not going to expect you to know those charges. We'll see how we can figure them out. But you don't have to be able to predict what they will do. So if I summarize this is the alkali metals, and they attain a charge of +1 when they react. Now, if they're just alone by themselves, they don't have a charge. But once they get into a formula, they have a charge. This is the alkaline earth metals. Here is aluminum, zinc, cadmium, and silver. All these blue ones, they can have a variety of charges, and so you're not responsible for knowing them. It's just when you see them in a formula, you'll be able to figure out the charge, but you don't have to be able to predict what charge they'll make. Nonmetals gain electrons, and so they become anions. The halogens are the second column from the right. Remember, the first column is the noble gases, and they don't react, so there's never a charge for them. The halogens are one column to the left of that. They attain a charge of -1 because they gain 1 electron. Oxygen, sulfur, selenium, they gain 2 electrons to get a -2 charge. And then nitrogen and phosphorus gain 3 electrons to have a -3 charge. We will also see that nonmetals will react with other nonmetals in covalent bonds, but right now we're going to focus on the ionic bonds. Here's a summary of that, the nonmetals. -3 for nitrogen and phosphorus, oxygen, sulfur, and selenium, and then these are the halogens: fluorine, chlorine, bromine, iodine. Okay, let's go on now. When you have an ionic bond formed, it happens because metals lose electrons because the nonmetals are pulling them off. It's not just like an atom will just spontaneously form an ion. It has to be that atoms react together to gain and lose electrons. So we will see that nonmetals pull electrons off metals. This gives the nonmetals a negative charge and the metals a positive charge. Here's an example. Here is fluorine. Okay, here's fluorine with its core electrons and the nucleus in the middle. And these are the valence electrons out here, 7. Here's lithium with the core electrons and the nucleus in the center, and it only has 1 electron in the valence shell. Now what we're going to do is bring them next to each other. Watch this electron as it progresses. Here's the fluorine, here's the lithium. When you bring them close together, the fluorine starts pulling on the electron. It distorts that electron cloud of lithium. Okay, what will happen is the electron sees a low energy place here on the fluorine, and it bops off and flies onto the fluorine. So after the electron goes from lithium to fluorine, fluorine now has an extra electron, and so it has a negative charge. And lithium has no electrons in its outer shell anymore, just the core electrons, and it has a positive charge. Well, lithium doesn't really have an octet in its core electrons because it's only 2 electrons down there, but it is like helium, and so it's stable. So when you have this kind of bond form, we call it an ionic bond, and you have the metal give up its electrons and transfer it to the nonmetal. The metal is a cation, the nonmetal is an anion, and this is key, the number of electrons lost by the metal atoms is exactly equal to the number of electrons gained by the nonmetal atoms. We say it's charge balanced. And then because you have a cation and an anion, they stick together in what is called an ionic bond. When we have this ionic compound, it must be charge balanced. So the number of positive charges, so whatever charge is on M times its subscript, is equal to whatever negative charge is on here times its subscript. So for instance, if M has a charge of -3 and a subscript of 2, there are 6 negatives. N must have 6 positives then. If N has a charge of -2, well then its subscript must be 3, because 3 times 2 is 6, and you have to have 6 positives if there's 6 negatives. Let's see an example with real atoms. Calcium will react with oxygen. Calcium is in the second column. It loses electrons to get a +2 charge. Oxygen is a nonmetal. It's in the column third from the right. It gains 2 electrons and it gets a -2 charge. So the 2 electrons lost by calcium are gained by the oxygen. The formula is balanced because calcium has a +2 charge and oxygen has a -2 charge. The number of charges are the same. But when calcium reacts with bromine, bromine will only gain 1 electron. So the 2 electrons lost by calcium has to be gained by 2 bromines because each one gains -1 charge. And we write the formula like this. Notice there's 1 calcium with a +2 charge, 2 positives. But there are 2 bromines, each with a -1, so 2 negatives. It's charge balanced. When lead reacts with oxygen, it actually can do a variety of things. It can either lose 2 electrons or lose 4 electrons, giving it either a +2 or a +4 charge. Oxygen always gains 2 electrons, so it has a -2 charge. When we look at lead, it can react 2 different ways. It can either make this lead where there's 2 oxygens. What's the charge there? Well, if you look at this, you don't know whether it's +2 or +4 unless you look at the number of oxygens. There are 2 oxygens, so 2 times -2 is -4. So lead must have a +4 charge. Here, there's only 1 oxygen. That means lead must have a +2 charge. So the number of electrons must be equal to the number of electrons lost must be equal to the number of electrons gained. So the number of positives equals the number of negatives. If you multiply your charge times your subscript, that gives you your total charge. A neat trick is that the charge here will become the subscript here, and this charge here becomes the subscript there because 2 times 3 equals 3 times 2. And so what you see is an easy way of figuring out what the correct formula is. Always make sure, though, that you check for the lowest ratio, because if you get 2 to 4, you know that has to be simplified down to 1 to 2. So keep that in mind. So going through aluminum with oxygen, aluminum has a positive 3 charge, oxygen has a negative 2 charge. See how the number of positives and number of negatives are equal? Positive 3 times 2 is positive 6. 3 times a negative 2 gives you negative 6. The number of positives equals the number of negatives. Why is it that this has to be? Because our formulas are neutral. If it's neutral, number of positives have to be equal to number of negatives. If I combine potassium with sulfur, potassium gets a positive 1 charge and sulfur gets a negative 2 charge. You can find that by looking in the pattern in the periodic table. So there has to be 2 potassiums and 1 sulfur. Ionic compounds do not form molecules. Now, right here, I'm showing you a formula, and we call them compounds. That's not a molecule, meaning there isn't a sulfur attached to 2 potassiums floating around. What you have is a crystal lattice instead, and the crystal lattice is going to be sulfur surrounded by a lot of potassiums and potassium surrounded by a lot of sulfurs, and they are in the ratio of 2 potassium to 1 sulfur. So realize they're not forming molecules, it's a crystal lattice, and this is what causes inorganic compounds, those things that we're talking about that form ionic compounds. Ionic compounds, when you hit them with a rock, they tend to shatter because it's a crystal lattice. Okay, so go ahead and try to form compounds with these elements, magnesium with nitrogen, etc. Now here you're going to make both compounds because iron can either have a positive 2 or a positive 3. Try making both of them. And here copper can either have a positive 2 or a positive 1. Make both of them. Magnesium with nitrogen, because magnesium has a positive 2 charge and nitrogen a negative 3 charge, you get this formula for charge balancing. Calcium, positive 2, sulfur negative 2. So if you just write one of each, it's charge balanced. Rubidium with phosphorus, because rubidium has a positive 1 charge and phosphorus a negative 3 charge, rubidium has to have a subscript of 3. Sodium with selenium, a positive 1 with a negative 2 gives you this formula. And aluminum chloride is a positive 3 on aluminum and negative 1 on chlorine, so there must be 3 chlorines. If I look at iron positive 2, see, which one is iron positive 2? Remember that oxygen has a negative 2 charge. There's only one iron here, so that's iron positive 2. Here, iron has a positive 3 charge. Negative 2 times 3 is 6, so you have to have a positive 3 here. Remember the crossing over the subscripts. It makes it easy to figure out this formula. Crossing over the charge as a subscript. Copper positive 2 is going to have 2 fluorines. Copper positive 1 only has 1.